Let us look at an application of PCA on the iris data. We use the PCA components to perform a multinomial logistic regression and check the performance. A multinomial logistic regression is an extension of the usual logistic regression that we have studied, where the response is still discrete, but it might have more than 2 levels. We will need the library caret, and then we are going to create a data partition to split the data into training and testing. We are going to use the library psych to create the pairs.panel. Here we see this plot which shows us the sepal length, sepal width, petal length and petal width on the leading diagonal. We also get the pairwise correlations in the corresponding columns and the scatter plots. For example, on the second row and the first column, we get the scatter plot of sepal length versus sepal width. While on the second column and the first row, we get the correlation between sepal length and sepal width. Next, we perform PCA on the training data. So we use the function peercom and we use center equal to t, that means we are centering the data, and scale equal to t, which means we are scaling the data. Then we see that we get the PC1, PC2, PC3 and PC4. Remember that if there are d original variables, then you are going to get d transformed variables. It's just that most of the information among the principal components are stored in the first few of them, so that you can ignore the last few principal components, and that is how you can reduce the dimension. The summary function helps us understand the variability explained by the principal components. So let us try to understand what we mean by that the most of the information is stored in the first few components. So notice that the proportion of variance that is stored in PC1 or captured by PC1 is 73.63%. That means if we ignore the next 3 columns, then we have already captured 73.6% of the total amount of information. If we ignore PC3 and PC4, then we can capture 21.9 additional information because PC1 and PC2 are uncorrelated. So that cumulatively, we have already captured 95.6% of the total information, and we can still ignore 2 of the dimensions. We can check the orthogonality of the principal components by using the pairs.panel. Notice that the pairwise correlation between these principal components is all 0, which means that they are all pairwise uncorrelated. So there is no information overlap between these principal components. Now let us try to perform prediction using the principal components rather than using the original variables. So I use the predict function with PC, train. We have created the train1 data frame using the pred and the train 5, that means the response. We are going to use the nnet package to perform the multinomial logistic regression. And we are performing the regression on the species, that is our target variable, on PC1 and PC2 only. Now, if you look at the confusion matrix between the predicted values created by the predict function and the actual values, we will notice that only 2 out of the test variables were wrongly predicted, and the accuracy was 93.33%. There are a lot of other information also, like sensitivity, specificity, that are class specific, and you also get a 95% confidence interval of the accuracy.